Italian company, which is developing the sentiment analysis engine and also customer experience analytics platform. Sentiment analysis enables a huge amount of applications, and yesterday we also had a look about some of them. However, the success of such applications depends a lot on the performance delivered by sentiment engines, and that is on how accurate they are in classifying sentiment. With this presentation, we are trying to know more about the state of the art about sentiment engines performance. So let's see some motivation involved. In the market there are available many APIs. However, sentiment engines nowadays do not reach 100% of accuracy, as it is well known, and they show misclassifications in multiple cases, even in cases that are straightforward for humans. So that is even in cases in which all of us agree about sentiment classification. And this phenomenon occurs both on industrial and on research tools. However, we have two different scenarios, I believe. In research, researchers are asked to develop sentiment classifiers working very well on specific settings, working on specific tasks like quality classification or iron detection, on specific sources or domains. For instance, there are international challenges working on just on tweets, or some of them working on reviews, and on specific languages, English, Italian, Arabic, and so on. So, on the other hand, we have industry and the market asking for tools which can get as input any textual source, from reviews, tweets, imagery. It's well known how different they can be. It's very short, reviews can be more structured, different grammars, and so on. And the goal of industrial tools is that they can be applied to general purpose applications. So, in this sense, we need industrial sentiment engines providing high average performance on multiple sources and domains. In this presentation, there are two sections. The first one, I'm going to speak about the perceived performance by humans by showing you some examples, very simple ones even. And the second part is more, we are going to show you an experimental evaluation where the goal is to measure, trying to measure the performance gap between general purpose engines and research engines, since the latter are built to show high performance of specific settings. And also we are going to see some differences between the two languages. So this is the outline of the presentation. I'm going to show you now some examples of misclassifications on simple cases, on difficult cases, and introduce the concept of cross-domain sentiment classification. And then the experimental evaluation between involving research and industrial engines on tweets and reviews. So we consider now these two research engines providing an online demo. iFeel platform allows to run 18 research methods, representing different methods, Stanford Deep Learning, and these free industrial tools, IBM Watson, Google Natural Language API, and our own industrial tool, Finsa to check. So let's see what happens in this very simple review. I hate this game. This is the iFeel platform, let's say these 18 research tools, and we can already see that some of them, very few, show a misclassification, even in this very simple case. If we go on, this is Stanford Deep Learning. In this case, represent correctly the sentiment, because it says that it's negative, the second. It offers three layers, let's say three levels. If we consider IBM Watson says correctly that it's negative. Now let's try to change the sentiment, and we see what happens with I like this game. we see that there are more research tools who are wrong, and but implementing different methods. These are also machine learning. There are some of them that implementing machine learning approaches. Here we have stable deep learning. In this case, it says that it's neutral. If we try the same with the Avion Watson, I like this game is considered as well neutral. Let's try now a more difficult sentence. This is a review coming related to the famous app Candy Crush, and it says, I just connected my game with my Facebook account, and instead of saving the progress, I lost all of my progress, and it came on level 1, although I was on level 98, please help. I believe that all of us agree that is a negative review. What happens here? Most of the research tools are wrong. Okay. Stanford Deep Learning, in this case, shows correctly that is negative. And in this case, Avion Watson that says that is neutral. All these variables are repeatable because they are all like that. So, what is happening? They are straightforward cases. Well, first of all, we can say that it is not possible to make any kind of generalization from the results that we just seen. It's not a comparative analysis with three straightforward examples, of course. It's not a scientific approach. In order to do that and to make some rankings between the solutions, we need an experimental analysis. What is happening is that polarity classification depends on many factors, and most of them depends, probably as we have seen before also in the previous presentations, on the training set, on the differences between the training set and the test set. And most of the scientific classifiers are better on some specific domains. For instance, reviews about movies or about politics, on tweets or on reviews in different languages. Let's try now to make it a little bit more difficult now. And we introduce the concept of cross-domain classification. In this review, the guy says, Candy Crush is my addiction, I love it. In this case, we see that the adjective addiction, which usually has a negative sentiment, like when it is used with about drugs, for instance, we found out that in the domain of games, it has a very positive meaning. And we can introduce the concept of cross-domain classifications. It means that it is well known in literature, and I'm mentioning many research works about this topic, because classifiers trained on one domain may perform poorly on another domain. And there is this quite new research area about domain adaptation techniques that is trying to adapt a classifier trained on one domain to work well on another one. This is even a very recent work from 2017. Let's say make it even more difficult. We see an example in which I believe we do not agree, all of us do not agree about its overall classification. I like this game, but after the iOS update, I get a crash when the app starts. Please do something. I believe that it's almost impossible that all of us agree because of the first positive part and the second negative part. Someone says, okay, from my point of view, I want to improve the product, so it's negative. Someone says, no, maybe the guy thinks that overall is good, is positive. It's well known in literature that the 80% in this paper has been shown that 80% of cases we agree. But what is very helpful in this case, I believe, is to go a little bit more in depth and to split to pass from the document level sentiment analysis to the sentiment level. So we should split in the document in more sentences. Here is an example of Google, of what Google does. In this case, it shows an overall neutral classification, which maybe it can be, but here they do not take advantage of the information of the positive and the negative part. And please do something is considered neutral. And if we consider the entity level sentiment analysis, a game has a neutral sentiment, crash as well. All of them, all of this highlighted entity has a neutral sentiment associated, which is, I believe, wrong. But it is also a design choice, which it can be improved. For instance, this is our own tool, up to check. As a design choice, we designed to split, to pass from document level to sentence level sentiment analysis, and to split where the polarity changes. This helps us to catch the positive part and the negative part, and also to detect accurately the sentiment associated with each entity. Okay, now we see the experiential evaluation. What we have seen so far, it's probably the activity that most of our clients, let's say, intuitively they do, and they have often a bad perception about the overall quality, but this is not the right approach in sentiment analysis. So how can we fairly evaluate engines? We need a benchmarks. First of all, a gold standard reference, and benchmarks in multiple sources and mixed domains. We consider here tweets and reviews. We took benchmarks from the last international competitions, from Italian language, Evalita Sentipop 2016, for the English version, Semeval 2017, and all of the engines participated. And we tried to add the industrial tools in this chart. It's a worst case, of course, for industrial engines, because here the research engines have been specifically trained to work well on these settings. About reviews, we took reviews from Amazon product reviews from this challenge. How we selected industrial tools? Okay, unfortunately, we found out that most of the commercial APIs do not allow, in the terms of service, to use their API in order to make a comparative analysis. In our opinion, this is a lack of transparency, and because it's a measurement tool, so we need to know about the accuracy. But specifically in sentiment analysis, because as we recalled, pre-trained engines can show a significant different performance depending on the target test set. So here we found out that Google doesn't make any explicit restrictions, so we took into consideration. We also took into consideration our own tool, of course, and which is the X2Check, the general purpose API. And here we have also some specialized versions of our X2Check working specifically on apps reviews, on tweets, on Amazon product reviews too, in order to understand what happens by changing the training set and the test set. So this is the chart for the tweets in Italian. So these are the tools participated, the official results from this competition, where we added the industrial tools. We can see here, I remember that it's the worst case for industrial engines, that, okay, these are this, let's say, F-score, the measurement, the indicators used by the organizers. We can see that the best research tool, which is on the constraint run. Constraint run is when a tool is trained only on the training set offered by the organizers. The U here stands for unconstrained. It means that they could be trained on a larger test set. So in this case, Unitor, for instance, with U is more comparable, let's say, with the industrial tools because it had a wider training set. But anyway, finally, after all of this, the misclassification that we have seen at the beginning, we can see that a delta in performance, a difference in performance between the best research tool and, in this case, the best industrial one is about 3.4% in the generalized, the general purpose version. The specialized one is a little bit better, of course. And if we go on, okay, this is the most fair comparison, it's about 1% difference. If we go on, okay, between X2Check and Google, there is a 10% difference. And in my opinion, it's very interesting to see, even from the scientific point of view, that Up2Check, which is mainly trained on apps reviews and not on tweets, is not the last tool in the chart, and there is also a little bit gap with Google. Okay, let's see the English version. There are 41 tools competed in this evaluation. We cut some of the results for space reasons, and this is a different measurement. They use the average recall to solve the tools. And so here we can see that the difference between the best research tool and the industrial one is about 12%. And that between X2Check and Google is a delta of 4.7%. Okay, now we see what happened about reviews. It's huge, let's say, there are 200,000 reviews here about Amazon product reviews, mixed domains. What we have seen, in this case, it's the worst case, the opposite perspective, the worst case for research tools, because they haven't been specifically, okay, they haven't been trained on Amazon product reviews. To be honest, temporal deep learning has a training set coming from reviews about new movies. So in this case, okay, we use the macro average F1 score here. Here there is a delta between X2Check and Google of 4.1%. And it's very interesting, in my opinion, that the best industrial tool in this chart and the best research tool in this chart have a difference in about 23%, very big. So it indicates it's a measure of the generalization power of the research tools. Okay, so this is just to recall all of the results, but I don't want to be boring. So overall, we can say that sentiment analysis is still a very complex task. And let's say just counting on the human perception about the quality of the engines is not a scientific approach. However, the manual inspection that we have seen at the beginning is very helpful in order to focus on the engine's defects and to understand the reason why there are these misclassifications and to improve the performance. And also it is necessary to evaluate the performance of a general purpose pre-trained sentiment with an extensive experimental evaluation covering multiple sources and domains. And okay, it would be this a note that it would be better if companies could share their accuracy value on different domains, because it's quite natural right now with the state of the art that the performance changes according to the source and the domain. And finally, the important concept is that domain or source specific models working well on specific domains and sources in general are better than pre-trained general purpose classifiers. However, applying domain adaptation techniques or recognizing the best specialized model to apply, thanks to that, it's possible to reduce misclassifications on the target domain. Thank you.
Okay, any questions? We've got another 5 minutes. Okay.
Thank you, that was a very interesting talk, and I think addresses something that this conference has really, in my view, missed, is the elephant in the room is how accurate are these things. And you know, you're looking at accuracy there where you're getting 30-40% wrong, which is, you can't really even use that for any kind of real level task.
Okay, the perspective of okay, if you are mentioning the results of the research tools very well fine-tuned on the test cases, okay, we have to say that usually the test sets from these international competitions are very hard. I can give you an insight about that and an idea. I remember very well an example for an Italian competition, which was, I translated into English, of course. It's about an Italian political reform, school reform of the school system. This school system is called, this reform is called the good school reform. Imagine how classifier can be good to understand a negative tweet mentioning the good school reform. So, okay, they are designed, this test set, to be, of course, very difficult cases. Okay, so I understand your point, but by making fine-tuning and to make domain-specific sentiment analysis, we can reach also high performance, because, for instance, in reviews we've seen here that we reach around 87% of accuracy. So it's possible to have good results, of course.
Yes, sure. I think you're right in certain specific cases, but I think most of a great deal of the conference has been talking around social media, which is not a easy general.
Yeah.
You know, there's obviously, like your good school reform, you see that in social media, those kind of examples all the time. I think it was very interesting that you mentioned how the API providers, who are in general not here, right? They're not at this conference, which I think is also interesting. How they don't allow you to compare. And I just wondered if you having worked in the area, have any views on you know, why are we working in a field where we can't even compare against the providers? You know, do you have any thoughts about that?
To be honest, it is an open question that I
would
it needs a
love to
discussion. Of course, I don't have. I can give you my idea. My idea, I already said in the contributions, that it would be more fair to show this accuracy, especially on each domain or on each source, because there are big differences. I think this would be the best, to be honest. But also, if you have a client, you have a specific target application, which is in fact somehow the most common case, if you think a little bit more, because okay, even if I have to analyze tweets, which are very difficult, but maybe my company works in a domain, of course, or a cruise or finance, and so on. So it's possible to build classifiers working well on these more specific domains. But I believe, I agree with you, and I believe that it's necessary to make some educational work to spread this information, to be aware that experimental evaluations are made.
Okay, we've got time for one more question.
I just wanted to speak briefly from the point of view of the people who run the benchmark competitions in academia. When I was doing organizing work for NACL a couple of years ago, we tried to get a lot of the providers to submit full demos and submit to some of the benchmark competitions. I think some people are worried that they'll not do well, but I think there's also a desire to keep certain things secret. Some smaller providers and all the big providers have a system they can sort of put out there and let people play with, but they have a better system that they don't. I mean, everyone also does this. But I think, you know, there needs to be a little bit more flexibility from the people who run the competitions as well as the providers to sort of make that work out. But I
Okay. Thank you. Okay, next talk is risk analysis using